speaker, Ms. Gajithira Puvanendran. Gajithira is currently working as a data scientist at Rootcode's Artificial Intelligence Division. With nearly 3 years of experience in the field, she has demonstrated expertise in predictive modeling, computer vision, reinforcement learning, and conversational AI. She holds a Bachelor of Science honors in industrial statistics from the University of Colombo, where she was awarded medals for her contribution to research and academic performance. Beyond her professional career, she is committed to contributing to the data science community. She led an open source contribution to RASA, one of the largest conversational AI frameworks, and has conducted knowledge dissemination sessions. She believes in using AI to not only to drive business success, but also to make a positive impact on society. So, Gajithira, we are so honored to have you here today to share your knowledge and insights on leveraging AI for business intelligence strategies. So, please welcome Gajithira Puvanendran.
Thank you, Devni, for that warm introduction. And I hope you can hear me clearly.
Yeah, we can hear you.
Okay, great. Also, I'm going to share my screen. That's visible as well.
Yeah, that's visible. Yeah.
Okay, thank you so much. All right, so good morning, everyone. First of all, thank you to the Women in Data Science Sri Lanka chapter for giving me this opportunity to sort of share a few things through my session with the data science enthusiasts and anyone who wants to, dip into the field of AI. So as Devni mentioned, my topic here today is leveraging AI for business intelligence strategies. So the topic is really broad, but in my presentation, I have structured it into 3 parts. So first, I want to sort of give an introduction to what is business intelligence and why do we need AI for business intelligence. And in the second part, I have curated a small example based on one of the actual use case I worked on. So that is related to demand forecasting in the manufacturing industry. So I will go through very briefly the steps and sort of the thought process that you all can have when you all go to build a demand forecasting model, for example. And the third part of my presentation will be about upskilling. So basically, I just want to share from my experience 3 set of umbrella skills that you all might need or you all might want to develop or might be helpful in this field for you all to continue working or enter the field or anything. So with that, I would like to go into my presentation. So in Zoom, I think there is a raise hand option in the reaction. So if you can you please raise your hand if you've heard about the company Netflix? I am not sure if I can see. Yeah. All right. Thank you. So there are a few who are raising their hand. They've heard about Netflix, right? I think now knowing Netflix, it's a huge word and it's asking, do you know what is internet, right? So in just to give this background, Netflix is a global streaming service. So you can watch videos or movies or any kind of video content online that is available in the Netflix directory. And right now, Netflix has more than 100 million users worldwide, but actually the origin of Netflix goes back to 1997, where it was actually a DVD rental company that has now evolved into a online streaming platform, right? Before I go more into the origin of Netflix, I just want to ask one more question from y'all. How many of y'all actually have heard the company name Blockbuster? Y'all can raise your hand if y'all have. Okay, so I'm guessing that's a no from many of you. So actually, Blockbuster was one of the leading video rental store, and it basically dominated this video rental market in the 20th century. And it was founded in 1985, so that was before Netflix, and it grew rapidly and became the place to rent your videos. Rent movies or documentaries or anything that you all wanted to watch that's available as a videotape. So when we look at Blockbuster, it actually peaked. The company peaked in 1990s and early 2000s. It actually had around 9,000 stores around the world. And since Blockbuster is like a DVD rental company, what it did was to make sure that it captured the market of this DVD rental. It actually had like made exclusive deals with Hollywood studios itself. So once the movies are released in the theater and it's out, and after like the showings are ended, Blockbuster made a deal with Hollywood studios to provide the new DVD releases to them, exclusively to them. So whatever movies that you want to watch, most of the time it will be available in Blockbuster. So this was in 20th century, right, where we watch movies by, there's a cassette recorder, you put it inside a VCR, and then you can watch these movies. But you have to rent this cassette recorder. So what happened is, these are like stores, actual physical stores, where you have all the movies, or not all the movies, you have a set of like a collection of various movies, and whoever wants to like watch a movie, they have to go to this store, and they might not even know what movie they want to watch, so they will just browse through the entire store to find that one movie that they want to watch, and then come home to like sort of watch it. So what happens here is like, this was okay for a lot of people to do, because right now when we think about watching movies, it's very kind of easy, right? We always first go and see if it's available online. We don't think much about renting CDs or anything. But at that time, it was like mostly that was the option to go for. Like if you want to watch a movie, the option that you have is to rent a video cassette or a video cassette, and then you have to sort of put it into the VCR and watch the movie. So that was like the options there. So what happened with Blockbuster was they leveraged that need of the people, and they even started imposing like, okay, for every movie that you rent, you have to pay this much of money, first thing. And the second thing is that there was also a late fee associated, because obviously now when you have take a movie and you don't return it, another customer who also wants to watch that movie might not be able to find it. So they have to account for that. So there was like this late fee that was like a penalty for the customers who didn't return the video cassettes on time. So this is how Blockbuster operated, right? So amidst all this peak time of Blockbuster came Netflix. So Netflix was actually founded in 1997, and it actually started as a DVD rental service. So what happened here is, they understood, okay, for Blockbuster, what's happening is like, it doesn't have an online presence. People have to go to the store, they have to browse through the list of like bunch of movies. There can be hundreds, 200s movies even, maximum. Like you don't even like, it won't even recommend based on your preference, right? Like how we have now in Netflix. You just have to go to the category that you want, or you might have to browse through the entire store to find something that you want. So there's no personalization there, and you have to rent. So Netflix co-founders realized like, we need an online presence, and we have to change the way that this is provided to the customers. So, and the other thing with Blockbuster was that the customers had to go to the store to rent the movie. So here what they did is, they had like an online directory, and then they delivered or like couriered the DVD to the customer. So it was like a DVD rental with a mail service plan. So that's how first actually Netflix started. And this was disruptive because at that time, that was like, for when Blockbuster was the only option, people, even though it was an inconvenience sometimes for them to go to the store, rent a movie, and then not be able to even return back on time and face a penalty, this was much more convenient for them. So that's how Netflix started. So this started disrupting Blockbuster's market in the or like the hold in the video rental service. So what happened was like, when we see this graph, we can see that the Blockbuster's revenue was at the peak in the 90s, and it started dropping down heavily. Whereas Netflix one, even though it was founded late, has been steadily increasing. So first, let's look at actually what happened to Blockbuster. Why that hit? Because Netflix did this, but Blockbuster also could have countered and done had some other innovation, right? So actually, what happened to Blockbuster? Why the stores were closed down and why did it go bankrupt? So when it comes to Blockbuster, the main thing was they didn't adapt to like changing the consumer preferences were changing in the market. People didn't have a lot of time to go and rent a video service and return it on time and face penalty fees because of that. And at that time, web services were slowly gaining prominence. So even they didn't adapt to the emerging technologies. The company kept on relying on physical stores and late fees, and this concept became very outdated when people figured, okay, we can even access content online, like stream and get content online, right? So what happened? The main thing that happened with Blockbuster was that it didn't understand what was happening in the market. It didn't understand the change in consumer behavior. So basically, the question is, did Blockbuster fail due to the lack of business intelligence strategy? So we can actually put that as part of the reason why Blockbuster failed, because it didn't look at the trend or understand what is the data right now on consumer preference. And based on that, the Blockbuster didn't make actually strategic decisions to come out of their traditional way of video rental services to an innovative approach. So basically, we can say it didn't analyze the customers change in the consumers' behavior or the market shift, anticipation of market shifts, and so on. So what has happened is that had led to its decline. So if you can see over here, now, when it comes to Blockbuster, what annoys the customers is buy this top, because Blockbuster is geared towards customers. So when you have no customers, you don't have a business and you end up closing down, right? So one of the things is it was time consuming for people to go and visit, in contrast when they can get the DVD rentals email to them and instantly access it. And in Blockbusters, they didn't have catalogs or recommendations or anything. So sometimes even in current cases, like, we don't know what we want. We just want to we might just want to consume content, but we wouldn't know what do we want to consume. So when we get recommendations, we really like it. But at that time, that wasn't the case. But Netflix was, even in the early stages, Netflix was able to sort of do that, provide some sort of an analyzed recommendation with some computational algorithms to the customer. So it looked a bit smarter than Blockbuster. And the other thing is the late fee. It was like a huge problem returning DVD rentals on time, because you have to go to the store and physically deliver them. But when it comes to Netflix, in the initial stage, they had like a monthly subscription. So you pay every month, you just pay this much and you can rent any amount of movies you want. And earlier stages, of course, both platforms, both companies provided DVDs, so you had to have like a machine to view that. But now that's not the case. So Netflix has mainly survived because it has used a data-driven approach to take decisions. So it has analyzed the market, the shift in consumer behavior, and also they even started using AI to enhance the experience of the customer who are using this platform. So as I mentioned, even in the early stages, Netflix had this complex computation algorithm that predicts the choice of a movie like for every customer. So it looks very personalized, but it was kind of primitive compared to what we have right now. But still, it looked very smart for them at that time. So from this, we can really understand that business intelligence is really important if you not only want to have a successful business, but to sustain the business. And when we couple business intelligence with AI, we can really elevate what we are offering to our customers and keep up with the trends and the shifts. So before we go into how we can leverage AI, first let's understand, like in the case of business intelligence, first let's understand what is business intelligence, right? So business intelligence is simply a process, right? You use technology, and the process includes collecting and analyzing the data. And data on its own might not be very insightful, so you analyze it and you deliver some actual like some sort of information to the operatives or strategists to make sound decisions. So this is usually done within a business. So what happens is when it comes to a data-driven decision making, you have some sort of evidence to understand what's really happening. And this evidence can really help you to make strategic decisions rather than doing only guesswork. So when it comes to business intelligence, mainly it has like many processes, but to keep it simple, it actually includes these 4 steps. So we need to collect the data that we want. For example, if we want to understand the shift consumer behavior, we collect the necessary data for that. And we have to do some analysis, because data on its own, as I mentioned, is not very insightful unless we see patterns and trends. So we need to do an analysis. And the other thing is, analysis might make sense to an analyst, but we have to present that to the actual decision makers and the strategies. So in that case, data visualization reporting is very crucial there. So what kind of a transformation we can see through business intelligence? I think the best case, as I mentioned, was Netflix. It was able to not only increase business revenue, it gained competitive advantages, and now they have even improved their operational efficiency, where you don't have to have a particular analyst to analyze millions of users' movie preferences. You have a model to do that. So actually what happens is, without BI, organizations really can't take advantage of a data-driven decision making. So no, those days what happened was, sometimes you need to make some intelligent guesses, or you use your previous experiences or accumulated knowledge to sort of take some strategic decisions. But that can be very hard even for people to convince their stakeholders that this is a decision that we should go for. But when you have the data is telling you or giving you hints about what's happening, and you can use that to make decisions. So there, the room for error is actually relatively less compared to subjective things like intuition. So business intelligence in the current era is extremely important, because we are actually living in a data-driven world. Like, there's so much of data that we are also providing, and that's being absorbed and all. So not taking advantage of the data means that you are actually falling behind. Like, your business will ultimately fall behind in what's happening with the world, in keeping up with the world. So that being said, BI is not something new, but the business intelligence that I am going to focus on was the business intelligence enabled by artificial intelligence. But why do we need artificial intelligence for BI, right? So for that, first let's look into the traditional BI approaches. So when it comes to a traditional business intelligence environment, what happens is, you have the IT department or some tech, someone in the computer tech role, like, who would collect the raw data. So whatever data that you need, you collect from various sources, and you have to sort of clean it and organize it, and you store it in a data warehouse. So now this data warehouse has the data that an analyst would need. So you provide this data to an analyst, and the analyst will query the data. That means they will go through the data, try to understand, extract the necessary information, and build reports and generate insights for the strategic decision makers. And what happens is, the data that you're collecting is mostly related to the past information, especially if it's related to your company, right? Obviously. So what an analyst would do here is, they reflect on the past data, create the analytics, and the organization will use the analysis to make the strategic and tactical decisions. So it's sort of like a retrospective. This happened, and you are going to analyze why it happened, and then use the analysis to sort of make your own interpretation of what the future could be, and then you all will make some decisions. So it's kind of like a reactive scenario, not a predictive scenario. When it comes to AI, we can go for a predictive scenario. We can try to anticipate what could be the future from this past data, and then take strategic decisions based on the predictions. So that's where AI-driven business intelligence can play a crucial role. So just for completion's sake, let's look at what is AI. So AI, which stands for artificial intelligence, is where you create machine systems or software systems that can perform tasks to the level of a human, that require human intelligence without any explicit programming. So basically what happens in this system is you expose a system to the data and it learns patterns and necessary information to make some decisions similar to how a human would. And why do we need AI in business? As I mentioned before, when it comes to AI, we can go for a predictive approach. So this is not to say that AI is going to replace the traditional business intelligence approach, but it's going to complement. So you need the traditional business intelligence approach to sort of reflect on the past data, but you can use that past data to also inform or help strategic decision makers to like offer foresight or some sort of guidance for them to them about the future. So if we make a comparison, actually, when it comes to traditional business intelligence, I won't be going through each and every one of them, but to give an overall view, as I mentioned, now when it comes to first thing, data handling, when it comes to traditional business intelligence, what happens is most of the data you expect it to be in structured form. So because you want to query, when you want to write queries, most of the time it's helpful if they are in the structured data form. But when it comes to AI enhanced BI strategies, you can even use like unstructured data from different sources and then convert it to structured form or anything and do a modeling, because AI enhanced business intelligence, basically you are doing some sort of there is mostly an element of modeling there, so not only analysis. So therefore, if suppose you need unstructured data, for example, maybe you want to inspect whether the product is a defect or not, and there you, instead of measuring the, for example, if it's a soda bottle, measuring the length and width and all that, you can look at an image and then see if the product is defect or not. So image is an unstructured data. So there, with AI enhancements, you get to use unstructured data as well. And the analysis type. So as I mentioned, in traditional BI cases, we look at what happened. So that's what we look at most of the time and try to draw insights from that. Whereas when it comes to AI enhanced BI, we look at what will happen. So that's called predictive and sometimes even prescriptive. That means what should we do? So you sort of like, this happened, what should we do? Like that, you can have different cases of how do we say, different ways of using AI for different approaches there. So it just not to answer what happened, but in the case of future, you can look at what will happen based on what happened in the past. And even decision making and traditional BI also, they are based on the past data, but here you can make like, so those are reactive decisions, right? As I mentioned, this happened in the past, so we make some intelligent guesses of what could the future look like, and then we make decisions based on that. But here you have AI doing that for you, so it sort of give you a idea of what the future would look like, and you use the future predictions to make proactive decisions. So if this is going to happen, let's take these mitigation techniques, or let's do this to make sure that we are able to either deliver things on time, or if it's something that's going to affect your business, then you all take those mitigation actions and so on. So similarly, there are like very like AI enhanced BI can really support and help businesses in many ways, and these ways actually complement the traditional BI approaches. So let's briefly look at like one simple example that I've curated just to see how AI can help to elevate businesses. So first, when it comes to business, I thought of taking what related to supply chain. So why I chose supply chain was like, supply chain is global and is everywhere. Like if I'm speaking through this laptop, it has gone through and these headphones, there has been a whole supply chain process that has brought this laptop to me. So it's a very vital sector in for any type of businesses. And this includes the supply chain process actually starts from the raw material sourcing to delivering the product to the customer, or getting the product, or it can even be services to our hand. So it is actually a network of several entities from the product creation to delivery. So when it comes to the supply chain process, even a hit in one of these processes can impact the demand for a product or what we get in our hand. So this is a very like it's very relevant for many business types. So I thought of just taking that and focusing briefly only on the manufacturing part. So in my supply chain process, I'm going to focus on the point of view of a manufacturing industry. So the manufacturing industry's job is to get the raw materials from its suppliers, create finished goods, and send it to the distributors. So when it comes to manufacturing, let me mostly think about product manufacturing. So when it comes to the product manufacturing, we have like let's say the production cycles can vary from depending on what is the product, the production cycles can vary and so on. So I just want to take a very simple scenario. So I have this table, and in this table, let's say your manufacturing, for example, your the manufacturing company is about for an automobile industry. So you manufacture parts like brakes, clutch, gears, and so on. And let's say this manufacturing industry has a fixed amount of like a fixed number of units it manufactures every month. So right now we are in March, and let's say next month, April 2024, it's expecting to produce 500 million of let's say brake pads. Okay. And suppose next month the company is seeing that, okay, actually among the 500 million brake pads, only 499 million have been sold to the distributors, or required by the distributors. So there was a surplus production there, a surplus of 1 million. So compared to 500 million, 1 million overproduction is just 0.2%, right? So the overproduction is only by 0.2%. But what is the cost of this overproduction? So I'm just going to take one cost and show how big it is. Let's say now when you produce or overproduce, you have to, like things like brake pads, you can store. If it's food, there'd be a wastage. But if it's brake pads, you can store. So let's say there is a cost associated with a storage. We call that inventory cost. So even if the inventory cost is less like $1 per unit, the cost for storing the surplus units is 1 million, and that's just incurred in that 1 month period. Your business has to incur a cost of $1 million just to store the surplus units. So even though you have only produced by 0.2% more, what happens is the cost is like 1 million. So this is can be very bad, or it can be very counterproductive for a business's health. For them, that 1 million inventory cost can actually be massive sometimes, even though it just overproduced only by a small percentage. So if you can forecast or have a forecasting model that can inform, okay, actually this amount of production is enough for the next month, you're easily cutting down a massive chunk of the cost that you might incur for an inventory for storage. So this is the kind of impact that AI-driven, like AI can have in a simple scenario like this. And here I'm not even considering any other costs, just the inventory. There can be several other costs associated with it as well. So just for this, you are facing $1 million cost is it can be large for the business and redundant even sometimes. So how do we manage it, right? So let's say you are actually your client is approaching you and saying, this is the problem I have. I want to have a forecasting model they wouldn't even say forecasting model. I want to reduce this. I want to make sure that we only produce a required amount of units every month. So this is where we can talk about AI in supply chain management. So in our entire supply chain, we just looked at from the manufacturer's point of view, one problem that the manufacturer is having, and that is there are cases where is a surplus production, and that's affecting the business revenue. So one now the AI use case that we can go to we can apply to solve this problem is demand forecasting. So demand forecasting is basically you forecast to predict the quantity or the number of products that you want to produce in a given time frame. And you do that by analyzing or using historical data as well as some external factors. So why is this forecasting crucial? So even in the example we saw, it actually can help business to optimize their cost, like reduce unnecessary cost. And not only that, if they know, okay, next month I need 400 million products units to be produced, they can plan their business according to that. And they can also even optimize their inventory according to that. So there are like several ways that the business can optimize itself just by knowing what is the number of units that I need to produce next month. So it's really powerful. So now in our story, as I mentioned, you have the manufacturer coming to you and saying, okay, I just need to know the exact amount of products I need to produce every month. So basically you want to forecast the, like as a manufacturer, you will send your products to a distributor. So you want to basically forecast the supply quantity for each product. So the manufacturing company can produce multiple products. If it's an automobile industry, a manufacturing company for an automobile industry, they can produce brake pads, they can produce brakes itself, gears, and so on. So you have to forecast for each product every month what is the demand for that product. So, or what is the shipment you have to send to your distributor on a particular month. So when we look at demand, there are actually several factors associated with demand, just broadly speaking. Let's say what you have in your inventory, let's say you already have 1 million surplus in your inventory, then if you need to like produce this much of, if you have demand for this, then okay, if you have this much in your inventory, how is that going to affect the demand for the products that you need to produce in the next month? That can be the case for the distributor also. If the distributor already has, if he or she couldn't sell some of the products to their retailers, they might have something in their inventory as well, and might reduce the demand for the product might reduce from the like what they request from the manufacturer can be less. So that can be a factor. Price. Then you have market trends, like for example, in the case of automobile industry, sometimes you suddenly have these regulatory frameworks coming in, so that might focus a lot on sustainability, for example, and then the whole manufacturer requirement to everything might change, or even some parts might not be preferred, or they might ask to change the material of the product that material that you use to make a product, and so on. And then you have economic conditions like inflation and so on. So there are several factors that are affecting the demand in that case. So you really need to understand what is the business and what is the task. So for a case of a manufacturing industry, or in your case, you have a particular client who is manufacturing automobile parts, what is their business? You need to understand that, and then only understand what kind of factors might be essential in order to do a demand forecasting. But that's not enough, because these are just us thinking at a high level. What we need to see is actually what data they have, so that we can actually see if we can build a model, and then look at how I can build the model, what data I have to build this model. So let's look at some example for like demand forecasting, what raw data you can have. First thing is, you would need the table with the product demand, or like the production units. So let's say you are going to do a monthly prediction, then you need to know, okay, for this product this month, what was the number of units produced, right? So you need to have that past information. Otherwise, we can't forecast, or it won't be a good forecast, because we don't have data to do the forecast. So this kind of data should be available for you. So that's the first thing, the number of units that has been produced or was in demand every month. The other one is you might need information about the product itself. So let's say you have something like magnetic brakes, and then you might have a table with the information of the products. Okay, this brake, what are the components you need? So these are the components that you get from your suppliers. What is the price of this the product that you're selling, at what price? Okay, is there a category that you have to look into this? And select that, you will have several information related to the product as well. And let's say you also have an inventory table. So this inventory table is telling you, okay, at the start of every month, what was the store like amount of units that was already in your storage or in the warehouse. So you have all this information. So what we can now do is we can combine the information we need. So we create this combined data. So for each date, we have the product, we have what category the product belongs to, the price, the number of units that was manufactured at that point, and the level of inventory at that point. So we have this combined data. So we have some features, right? We have the feature like inventory of the manufacturer, we have the price, we have the amount of units produced in the past, and so on. But let's say in this previous table, like we saw several factors, right? Let's take market conditions, for example. Now, the thing with market conditions is not all market conditions, like first of all, the market condition is an external data. So when it comes to automotive industry, the market conditions, what comes under these market conditions are like consumer sentiments about the product, maybe then technological advancements, and mainly like regulatory changes, as I mentioned before. So there are some market conditions that you can record and some you can't anticipate even. So when you are going through the features of the like what features you would need for your demand forecasting, first we will look at what data we have, and then we might think what data is missing. But not all data can be used for our prediction model, because let's say regulatory changes happen once in a while. So at every monthly prediction, we might not have a regulatory change. So we need to think at that point whether we want to include market conditions or particularly regulatory changes within our features. And that is a decision that you have to make as a data scientist with your client, and you need to see whether you can gather those data and include in your model in the frequency that you want. So if you want a monthly prediction every month, will this information be available to you? So like that, when it comes to features also in this modeling, as a data scientist, we need to think about these things. So let's say I've talked with my client and we are thinking, okay, market conditions can be unstable. So that means it can affect the model's forecast. So for now, let's just have like a baseline implementation without this external information like the market conditions. So then we have this data, but are we missing anything here? So we actually have the date, product name, category, and everything. So what are we missing here? We are actually missing the time series related features, because we are doing a forecasting. Forecasting is basically related to time series. So we want to forecast next month, means we need to have the sequential data from the past 12 months at least, for example. Then what we have in this table does not have the information. So time series related features, how can we get it? So there are ways to internally process your data to get those features. So let's look at two such features. One is like the lag feature. So let's say I want to let's say we are thinking about predicting for next month. So and I am thinking, okay, so in order to make the predictions for next month, I need to know what was the demand like in the current month. So that is a lag. So I look back by 1 month. So in that case, we call those features lag features, and you can use all these statistical techniques to sort of see which lag is more correlating with your feature. So here, when you have like a high correlation here, then the lag one is very important. That means in order to make next month's forecast, you need the current month's demand is very important. And the other thing is called moving averages. So in moving averages, what happens is you sort of look back, like take a window, let's say the past 2 months, and then you average the demand in the past 2 months and include for the current month, for example. So like that, what happens in these time series related features, you're capturing the essence of what happened in the past and in creating those as features. So here I have done one example for lag. So I'm looking at the past month and incorporating that information to my table. So let's say in 2023 for February, for this set of product, I'm adding a lag by 1 month. one month. So that means if at 1st of February the demand that production was 182 and it was 50 last month, like that we create these lag features. So what happens is these can capture the sequential information and you incorporate that into your data. So when it comes to demand forecasting, these time series related features are very important. Then you go into the modeling. So I'm not going to discuss the models that you can fit, but I want to convey what kind of a thought process that you need to adopt for modeling, because what model you can fit is going to be heavily depending on your data and several other factors, and you can find these information in the internet. But what sort of an approach as a data scientist you need to take is to be open to experiment with many models. You can't just look at data and be like, okay, this is the model that I can do. You can eliminate some models based on some assumptions, or if those assumptions are not fulfilled, you can eliminate the model that you want to fit. But it's always a good idea to experiment with models so that you can understand, because like what we say is not even as any no like all models are wrong. That's a general idea, but what model works best, that's what we need to do. So experimenting is really key there. And another thing is, you can even, like, let's say you have a data, like I mentioned, in the data you have something like a category. So you can build a forecasting model for a brake system category, products related to the coming under the brake system, and another model for a product coming under the transmission system. So you have models exclusive for each of these categories or clusters, and you train them separately. And then what you can do is you can have like sort of like an ensemble learning there, and even have like better models. So when it comes to modeling, just knowing what is the model that you need to fit in, what is the model that you want to apply is not enough. You have to like think of different approaches to modeling itself. Like, whether am I going to create clusters of my data? Am I going to use multiple models and combine the learning to make the forecasting, and so on? And then the other important thing is the metric. So if you want to know if your model is doing a good job, you need to have a good metric, right? So there are some common metrics that people use, like mean absolute error, and like root mean square error. So I won't go too much in depth into this, as assume most of you are familiar with some of these metrics. And then you have mean absolute percentage error. So basically what these errors measure is, you have in the past data, you use the past data and you build a model that can forecast, and you compare the actual values, because it's a past data, you have the actual values against the forecasted values, and you check how off your prediction is. So if your prediction is off by a lot, or your forecast is off by a lot, you have a higher error. But if it's not that far apart, if it's close, then the error is low. So what metric you select might not only depend on you, but also your client. So they might sometimes prefer to see the quantification of error in terms of percentage. So there you might need to present your results using the MAPE method. That's a mean absolute percentage error. But sometimes what happens is, now in all of these cases, we are not penalizing a forecast that has over forecasted or under forecasted certain products, and sometimes that's what you might need. So you might have to weight your predictions. So in that case, you might want to use something like a weighted mean absolute percentage error. So this weight will sort of give you add weightage to over forecasting or under forecasting, and that way you can have a better like, at least for me, weightage is really important, because then you have a better sense of the error, because sometimes it can give wrong information when you don't weight it and treat over forecasting and under forecasting in a similar way. It really depends on your business, whether you want to, for example, in some businesses it's okay to overproduce, but it's a definite no to underproduce. So there you might have to add more weight to a forecast that is telling you to produce less number of units. So if you look at this example now, when it comes to, this is a mean absolute percentage error. So there is a forecasting model that says Monday you need to produce 55 units, Tuesday 2, and Wednesday 50. And the actual sales that was in the record was Monday there were like 50 sales. So the error is like 10% there. And in Tuesday it's like 1. So it's like a high error there, and so on. So here what has happened is, just even though only one unit has not been sold, it's showing a higher error. But when we weight it properly and give more weightage for like when the sales are higher, when you have a higher sale and then you wait for the higher sale there, then your error percentage is actually low. So therefore, the metric selection is also really important when you go to build a model. So to wrap the part of our client's story where you're having a manufacturing company reaching out to you, it's really important for them because first of all, like this entire supply chain can be disrupted if you don't meet the demand. So you need to optimize your supply chain, and supply chain also includes not only just production, right? There's so much of logistics and procurement plans and everything. So it can really support in supply chain optimization, and you're making data-driven decisions. So when you know, like, okay, this is how much you need to produce, or this is what's your forecast is, you can plan your inventory to production and resources according to that. And not only that, you can also do inventory optimization. So if you know this is the kind of demand that you have, then you can optimize your inventory according to that as well. And obviously, as we saw before, sometimes it can hit our revenue when we overproduce. So in that case, when we know what is the amount of units we need to produce, when we have a forecasted model for that, it can even enhance our revenue. So there are several use cases when it comes to manufacturing industry. What we saw was one use case, which is called demand forecasting. The other one is like predictive maintenance. So here you can see, like, you can use AI to, I think Sachin also mentioned this. So you can use AI to know if any parts in your manufacturing industry or in your factory needs to undergo maintenance. So if you can anticipate that, then you don't have to be at a loss of when something actually happened to a particular machine and you have to stop production because of that. This is really crucial. The other one is anomaly detection. So you can like have capture the images of different products, and you can immediately see, or rather in very quickly, like in less time, you can see what kind of whether are there any defective parts. So is this a high quality part? Like that, you can have a classification there. So not only demand forecasting even in the manufacturing industry, but even in the manufacturing process, you can incorporate AI to make it better. So like that, there are several AI use cases when it comes to manufacturing companies. So since we focused on manufacturing mainly because of supply chain, I just highlighted this. But even things like demand forecasting, we can use it in several other, like the forecasting technique itself can be used in several other sectors. So that's the beauty of AI there. You have these techniques that can be applied across several industries. So here also I've just mentioned briefly some of the AI use cases that comes under the manufacturing. Once I haven't mentioned are like scheduling the like making a plan. So even demand planning can be done by AI with the right amount of data and good quality data. So the final part I want to focus on is the upskilling. So as I mentioned, now when we look at AI enhanced BI, there are like, as a data scientist, we need to sort of understand what kind of a method we want to go with when someone comes with the problems. That's what we saw earlier, right? I just took through the steps of, okay, in this case, you have this problem from this manufacturing company. So you want to do a demand forecasting, you need to have the data, you need to make certain calls, you need to like understand what features you can include and you should include and can include and can't include, as well as then in modeling what actions you have to take, and metric selection also how you should do. But all of this can boil down to some of the skills that you want, like the fundamental skills that you need to develop in order to convince or even undertake such tasks as using AI for enhancing the BI strategies. So the first thing, obvious thing, is the technical skills. Right now, AI enhanced BI is mostly very reliant on programming. You have tools, but sometimes it's actually easier to sort of, because sometimes some tools can be restrictive. So when you, as a data scientist, when you have the programming knowledge, you can do your own analysis and you can make connections between data and so on. And that is very crucial there. And right now, the most prominent programming language in our field is Python and R. So knowing that or having the fundamentals there is very important. And the other thing is machine learning algorithms and techniques. So as I mentioned in modeling also, when you have a certain problem, you need to know, okay, what kind of an algorithm or what kind of a statistical approach, for example, I can fit for this model. So when you have the fundamental understanding of those models, then even if your model is not working, you can understand what went wrong there. So you need to know those fundamentals. And the other obvious thing is you knowing how to visualize your data. So you have tools like there are tools like Tableau and all that you can learn to help in showing very graphical representation of your data. So that's very crucial because you need to present these information to your client or to any strategic decision makers. And of course, right now AI has become easy because of several frameworks and libraries. So knowing those libraries and what's in trend can also be very useful. The other main thing, and I think it's very crucial, is domain knowledge. So you might be familiar with Python, you might be familiar with different models, but as a data scientist, what's really important is you need to make a rapport with your client. So your client is coming with this problem and you need to understand what do they want to what do they want out of this. So you have to understand, okay, what is their business objectives. And even though in our forecasting model I mentioned metrics like mean absolute percentage error that you use to measure your model, what actually the businesses are interested in, their business metrics. So for example, from this forecast, what is the reduction in the cost? That can be a metric that the business is interested in more than, okay, this is the accuracy of my model. So you need to understand, oh, sometimes it's you who might need to propose those business metrics to your client. So domain knowledge is extremely important, and industry specific knowledge as well. So for example, I am currently working in a demand forecasting case and inventory optimization for a automobile industry. So in that case, I have to understand about that industry. I need to understand about car parts. I need to understand about what is the product that they are selling, and not only the product listing, but their business and their customers and who are they catering towards and what is their target market. So like that, you need to build that domain knowledge. So it's more like you're doing some kind of like intelligence work on your own to understand the domain knowledge so that it's easy for you to liaise with your client and understand like what is it that they need. So then you can transfer that knowledge into your into an AI problem. So you need to transfer the business problem into an AI problem. So for that, you need to first understand what is a business problem. So domain knowledge is extremely important. So you can do that by researching about similar
Really?
cases. Sorry.
මෙහි බංකල.
Then most of these people refer to this as soft skills, but I like to call them as power skills. So for a data scientist, these skills can really set you apart, not only in the place that you're working with, but with your client, because you're the one who's directly talking with your client, right? So when they see you, they are seeing your organization and you're representing the organization and the work that you all do. So some of the power skills that you really need to have is definitely communication. You need to convey what your outcomes are, what are you planning to do in a non-technical manner for your client. So we can't be going and talking in technical terms there if they don't understand. If they understand, it's a difference, but if they don't understand, we need to know how to convey that. So communication and presentation can be like presentation skills means knowing how to present your results in a way that they can understand is really important. And the other thing is critical thinking and problem solving, meaning that your clients look at you and see whether can you understand what they're trying to say. So the best way you can do that is not by repeating what they say, but by asking the right questions. So when they mention or come with a problem, you are thinking in two heads. One, okay, this is a business problem and this is what it is. Now, can I do this always using AI? So you need to make the connection there and ask the right questions. So that can be really helpful, or really powerful actually, when you are talking with your client, because they get impressed by you. And then it is through these questions that you can understand more about what they want. And you need to collaborate with them. So you can't keep your client aside and do the work, but also the client doesn't want to be disturbed all the time because they expect us to do the work. So there should be a level of collaboration with trust that can like that, where they know that they need to be there for you, even though that's an ideal case and that's not always possible, but trying to build that collaboration can be very helpful. And the other thing I think is very important is be curious about the data, because most of the time in these cases you will get like massive amount of data, and it can feel exhausting to like sort of understand what is the data that you want to use, and how do I now make a, combine this data and build all these models. So rely on your curiosity, because it's not good to ask questions to your client when the answer is already in your data, right? So you need to go through, and sometimes the data that you get, you can't understand it at all. So you need to go through your data, be curious about what the data is trying to tell you, because when you have the data and you go to your client, okay, I have this data, but I don't have this data, then they can actually help you to give the data, or be like, let's not focus on that, we'll try to build with what we have, and so on. So it's very crucial, because the quality of the data is going to affect the quality of the solution that you are building as well. So when you've developed that curiosity about the data, you won't feel exhausted by this kind of work, but actually you will try to, at least for me, what happens is I try to like uncover these, what is the mystery of these data, and that kind of can help me to ease my work when it comes to actually building the solution. So with that, I would like to like finish my presentation. So I wish you all the best to start your upskilling journey. And if you all have any questions, I'm open to answer them as well. Over to you, Devni.
Yeah, so